At last it has come, Harry. We are at war. Now we shall see the beginning of the end of these Nazis.
I wish I could believe that. But I am afraid we are coming in too late. Nearly all of Europe is in the hands of the Nazis today. They have held our country, Belgium, for more than 19 months. They are strong in men and material, and they may win a complete victory long before the United States can equip an army.
You may be right, but you look only at the darkest side, Henri. Why must you do that?
I can see only the facts, Hubert. This war calls for a new kind of weapons, and Germany has them in abundance. Men for armies we can get, yes, but the equipment to fight with is something else. That may come too late to prevent a German victory.
Henri, you are too pessimistic. This country has the greatest productive capacity in the world.
In many things, yes. But there are gaps to fill. Take our own industry, for instance. Who dominates the world in the optical field? Germany. So, what army has the best optical devices for war? The best rangefinders, the best cameras for air reconnaissance, mapping, and intelligence? And who is likely to have the best sighting devices and gun directors? Germany, of course. What could our guns without precise optical fire control devices? Lack of these may make a difference between victory and defeat.
Maybe so, but this country can make such devices. Perhaps not as good, but good enough.
Not in time, Hubert. The capacity of our optical industry for such things today is only enough to equip a few divisions, much less several armies. Don't forget, it takes years to train lens grinders to do precision work. Time fights on the side of Germany, and they may win because of that advantage.
We argue to no purpose, Henri, but win or lose, we are at war. Now, we may be asked to help, so let us think of our own problems in the shop in case that should happen.
Of course they were asked to help, and they did. They and many like them who merged their special skills into our gigantic arsenal of victory to achieve a miracle of production without precedent in the history of the world. By the end of 1944, we had built 1,800,000 army trucks, 68,000 tanks, 2,800,000 big and medium guns, 15 million machine guns and rifles, 45 billion rounds of ammunition, 43,400,000 bombs, 196 million uniforms, 98 million pairs of shoes, and 187,000 planes. But that was only part of the job. We had also built an undisclosed number of battleships, cruisers, aircraft carriers, submarines, naval auxiliaries of all kinds, and tens of thousands of landing craft. In shipyards all over the country, scores of cargo vessels slid down the ways daily to carry men and munitions to combat areas. And wherever American guns blazed on land, at sea, or in the air, they were equipped with sighting devices and fire control mechanisms equal to or better than anything the long overrated optical scientists of Germany could produce. That was accomplished by expanding many-fold the capacity of our optical industry, by drawing into it companies like Argus Incorporated, whose pre-war business was the building of cameras. To Argus was assigned the task of converting to the production of precision lenses and prisms, a field in which they had very little previous experience and practically no manufacturing equipment. They started strictly from scratch. The making of Argus cameras was ended abruptly. 4 warehouses in Ann Arbor now contain the machinery and unfinished material for camera production that had to be moved out of the factory to make way for the new war project. Invaluable assistance was made available to Argus by the Frankfurt Arsenal, where facilities for optical research and experimentation have been in operation since the last war. Fortunately, Argus had a small group of experienced optical technicians and a few apprentices who could form the nucleus of a supervisory production staff. The difficult problem was to break down the established routine of optical assembly so that unskilled workers could be taught to perform one operation efficiently. There was no precedent for this plan. It had never been attempted. But it was accomplished by devising new techniques and new machinery so that a relatively few experienced workers could train and supervise the inexperienced. However, there is still no substitute for long years of training and experience in the performance of certain precision lens finishing operations. For instance, in this delicate test, a master lens polished to extremely close tolerance is carefully fitted over a nearly completed lens, and the two are viewed under a monochromatic light source. The number of Newton rings or bands, their width and spacing, indicates to the skilled craftsman exactly how many millionths of an inch must be polished away to bring the lens down to its correct dimensions. The original Argus plant, which had built thousands of cameras, was not large enough to meet the production schedules for lenses. With government cooperation involving financial aid and high priorities for critical construction materials, a defense plant was built in record time. Later, a second story was added to provide engineering and research facilities, indispensable to the maintenance of high precision standards. The computation of a lens is as vital to its perfection as the highly skilled operations that produce it. Long and intricate mathematical formulas must be worked out to determine exact dimensions and curvatures. Engineering, as applied to lens manufacturing, must concern itself not only with design, but also with methods of production control. The physical laboratory must carry out a constant routine of precise and elaborate tests to ensure that the standards demanded in lens production are maintained. The instruments used for this purpose are the most delicate and accurate ever devised. Chemistry plays a vital part in the development of cements and lens coating materials, which are constantly being improved through research. And all such materials must be analyzed before use to make certain that the prescribed formula has been followed. Lenses must be chemically cleaned to guard against the growth of fungus, which obscures the lens surface. Moreover, Argus production was not confined entirely to lenses and prisms. Complete fire control devices, such as sights and observation telescopes, became part of the program. Special machinery was installed for this purpose, and skilled operators had to be found in a highly competitive labor market. production of a lens begins with a blank of optical glass, which is first roughed ground to the approximate thickness and curvature required. This is followed by a finer and more precise grinding operation, which further prepares the surface of the lens blank for subsequent polishing. By means of these machines, which have a curious wobbly motion, the lenses are ground and polished with progressively finer grades of special abrasives and metallic oxide until they are brought to dimensions so that the surfaces are spherically accurate to 5/millionths of an inch. Meanwhile, a surface finish has been attained that rivals the luster and purity of a precious jewel. Before lenses can be mounted for use, they must be centered. That is to say, the optical center of the lens must be determined by test, and the periphery of the lens ground so that it is equidistant from the true optical center at all points. Practically all of the lenses now produced by Argus are fluoride coated in high vacuum evaporation chambers, which in effect plate the lens with a microscopic film that substantially improves its light transmission and performance. Each surface of an uncoated lens reflects about 4% of the light seeking to enter it, and a standard telescopic gun sight reflects about 50% of the light. A coated lens loses only about 1% of the light at each surface, decreasing the light loss in the complete gun sight to about 15%. In terms of camera use, this means that a coated 3.5 lens can transmit 15 to 25% more light, depending on the number of elements in the lens. With this hard surface, low reflection coated lens on the telescope, it is possible to see better under poor light conditions. And clear, sharp photography is possible 45 minutes earlier and 45 minutes later in the day. Post-war cameras undoubtedly will be equipped with coated lenses. Another very important characteristic of the coated lens is that a gunner can bring his sights to bear on enemy planes attacking close to the sun because glare is materially reduced. In the assembly department, where sights and scopes are put together, absolute cleanliness is essential. Every speck of dust is removed from lens and prism surfaces by means of small vacuum hoses tipped with soft fabric. This is extremely important for lenses that are to be cemented together to form doublet or triplet elements, because a dust particle between the sections would become a permanent defect in the lens. Cementing together the elements of a multiple lens of this kind is an operation requiring skill and delicacy. For this operation, Argus developed a cement that will not separate or discolor through a temperature range from 60 below zero to as high as 260 above. Lenses and prisms comprising a wide variety of sizes and types have been engineered and produced by Argus. Many are used by other manufacturers, but the largest number assembled into complete optical devices in the Argus factory. One of these is the model M49 observation telescope, a very compact and efficient instrument used in large numbers by our Army and Navy. This is a pre-war Argus product that proved itself so much superior to other available types that it was chosen as standard equipment by our fighting forces. It is used primarily for artillery spotting and for use in advanced reconnaissance posts to observe and report on the disposition of enemy infantry and mechanized armor. This small elbow telescope seen here in process of assembly is a vital unit in the fire control aiming device used with Army pack howitzers. These guns are designed to be carried into remote and otherwise inaccessible positions on muleback or by parachute and airborne equipment. They have seen action on all war fronts, and particularly in the Pacific area where their ability and terrific firepower have combined to match enemy resistance on beachheads and in mountain fighting. The 105mm tank howitzers, which have put thousands of enemy tanks out of action on all fronts, are equipped with an Argus-built sight. This sight is approximately 21 inches in length and is fitted with 11 optical elements comprising 5 doublet and 6 single types to provide 5 power magnification. Argus supplied 3 telescopes vital to the operation of this gun director mechanism that sights and fires anti-aircraft guns. This telescopic gun sight is a project of which Argus is justifiably proud. It was conceived and built to meet a crisis that threatened the success of the Allied campaign against Rommel in North Africa. Argus engineered the production of this device to meet specific requirements. A large order required delivery within 30 days. And by working special shifts, day and night, Argus did meet what other sources of supply had termed an impossible deadline. It is known that many of these sites were in action against Rommel's tanks, and their use in the Battle of El Alamein contributed in an important way to the defeat of Rommel. In the midst of all this preoccupation with the production of lenses and precision optical devices, Argus also became an important source for certain electronic assemblies used in radar equipment. Previous experience in the manufacture of cadet radios was helpful in solving engineering and production problems to meet delivery schedules that called for relatively large quantities to be built in the shortest possible time. On this pre-war production line, thousands of Model E cameras were built. The valuable experience gained at that time resulted in an order from the War Department for even greater quantities of the well-known Argus C3 for exclusive shipment to our armed forces overseas. Delivery schedules for these C3 cameras were such that Argus found it necessary to set up a monthly production rate exceeding all pre-war production records. However, these projects were an additional contribution to the hundreds of thousands of lenses and optical devices produced by Argus for war use when the need was critical and the time was precious. They played a vital part in knocking out the air armadas of Germany and Japan, and in devastating raids on enemy industrial centers and troop concentrations. They sailed with the fleets to aid in naval victories that sent the fighting ships of our enemies to the bottom of the sea. Argus products served the big guns that cleared the way for Allied advances in Africa, Italy, France, and Germany. They landed on the beachheads at Guadalcanal, Saipan, Leyte, and Iwo Jima. They were truly the Argus eyes for victory. The precise, impersonal, deadly eyes of firepower that blasted a path straight toward Berlin and Tokyo. And in post-war years, the facilities and personnel acquired by Argus will become part of a greater American optical industry that can take and hold world leadership. Argus management and factory employees are proud of its 4-time Army-Navy E Award that flies over their plant. It's the recognition of their patriotic efforts to solve manufacturing problems and set production records that called for new skills, new methods, and new standards of precise workmanship.